screen. So we're going to share my screen to what we were doing last time and kind of get back into it. But before we do, are there any questions on the homework that's due today?
There was like 2 questions. I mean, I already turned it in, but there was like one of the questions is the Z-score one.
Yes.
When it was asking to find, I think it was, one moment, let's see if I can stay. Okay. Give me one moment to pull it up.
So I'm pulling it up also.
I believe it was number 2 from 6.1. It was E and F, if I'm not mistaken.
Okay, let me get there. Okay, so number 2, E and F. Yeah. I was wondering if somebody was going to ask about these. Okay, so I'm going to actually show you how to do these. Remember, the homework's not due till midnight, so you're more than welcome to go and change it and upload it again. I'm going to go ahead and open up a program that will help me let me draw nicely, as opposed to what I was doing the other day. Oops, hit the wrong button. Hate when I do that. Okay. Do that. Okay, here we go. Smart notebook. Okay, so what this one is asking us to do is asking us to find the Z-score if we know the area between is 95%. So we're going to do number 2. So 6.1, number 2, part E. Okay. So I'm just going to write it here so you can see what I'm doing. But it's 6.1, number 2, part E. And it says the area in between is 95%. So what I want to do is, and it even says hint draw picture. So what kind of picture am I drawing here?
A bell curve.
A bell curve. So we're going to draw a bell curve. And I think I even say that we're between 2 Z values. So here's one Z value and here's another Z value. We'll call this one Z1. And this one, actually, we don't even need to call it Z1. So one of the things I notice about this is it's between 2, it means that they're the same value, they're just on opposite sides of 0. So the center of this of a Z is 0. So this one's a negative Z and this one's a positive Z. And we're saying the area between these two is 95%.
Oh, so I just have, okay.
So one of the things remember on this is that R always wants to know the area, either the lower tail or upper tail. The lower tail I think is easier to find. So the R wants to know this area here. If I can give it this area here, it can tell me this Z value. So I know this whole thing here is 95%. Do I know how much is in this part of the curve from here all the way over? How much is in there, do you suppose?
Sorry, it
So
froze.
how much of the, and I gotta warn you, my internet at home is not always the best, so sometimes it breaks up a little bit. But how much of the area is all of this side?
That'd be 50%.
50%. Okay. So if this is 50%, can you tell me, and I'm going to use a different color here, can you tell me how much this would be?
It would be half of 95%.
Yeah. So this is the half of the 95% that we already have. And half of 95%, I think it's 47.5.
Yeah.
So if this is 47.5, can anybody tell me if the whole side's 50% and this side is 47.5, how much is in here?
2.5.
Yeah, because it's the 50% minus the 47.5. So this is going to be 2.5%. Okay. All right, so that's all 2.5%. So now I can go and use R, and I can use the Q norm.
That explains it because you're doing Q norm there. Okay.
0.025, because Q norm gives me the Z's. I have a probability I want the Z, so I need Q norm. I use P norm if I know the Z and I'm trying to find the probability. Think of it as P norm gives you a probability, Q norm, I don't have a good thing for that one, but P norm will give you a probability. So if you have the probability, which we have in this case, you want Q norm. And then you just
So
type in
when
0, 1, and lower tail equals true. What was that?
So when we're dealing with a normally distributed curve, and we're trying to tell the between two z scores, are they always going to be equidistant from the mean? In this-
If we're saying that we're 95% between two, then we are going to assume that they're equal distance from the mean.
Okay, I think that's what my problem was. Is
Yeah.
I was not assuming that. I was not sure where they were.
So by that, are you saying then once you put in that Q norm and then lower tail true and you get the value for that, that would just be the answer? You do
Yeah,
a
so-
negative for that one and a positive, or?
It'll give me the negative, and then I can just make the positive to get this one. I can just
Okay.
change the sign. I don't need to
Okay.
do anything to find that one besides change the sign.
Okay.
Does that make sense?
Yeah.
Everybody's cool? Any other questions? Now, Angela, I'm sorry I didn't get a chance to email you back. I will look at that after class, okay?
You know, so I tried to refresh it and lost everything I had done. So it's all right. I already restarted it.
Okay, but it's working now?
Yes.
Okay.
So I will tell you from what I had found out, apparently if you try to do the shortcut of just capital T instead of writing true or capital F, it causes like a bug or something and like freezes. So
Oh, interesting. I did not know about that. So don't do that.
yeah, don't do that.
Don't do
Just-
that. Because I always thought you could use T and F, and I didn't know that that would cause a bug. So let's not do that.
Yeah,
I'll keep that in mind now.
exactly.
All right. Any other questions? on homework.
I thought I had one. I'm just looking real quick.
Okay.
Okay, I don't see it. If I think of it, I'll email you.
Okay. All right. Okay, then let's move on to where we were last time. So I want us to go back to the section 7.1 material. And I'm actually going to go into this little app that I was showing you last time, and I want to talk a little bit more about this. And we were dealing with, last time I was dealing with income poverty, and then looking at home type, right? And so we were kind of talking about this. We were looking at whether the means are different, and those means definitely look different, don't they?
Yeah.
Yeah. But then the question is, are they really different, or is it something that is because of chance alone? And so that's what we kind of have to answer is it real, or is it just by chance? So we want to kind of find a process that will answer that question for us and see how that process works. So that's what we're kind of working on now, is we're working through that process. And we have this thing called a hypothesis. And that's what we call, again, everybody in literature calls it the alternative hypothesis. I don't particularly like that answer, but it's what you're trying to guess. It's what you're trying to research. It's what you're trying to actually make a question about. So it's your conjecture that you're trying to actually work through. We have this thing called a null hypothesis, which actually assumes that the difference is by pure chance, that there really is no real difference going on. And so this is kind of what we go through, and we're going to look at kind of the steps we go with a hypothesis test. So the very first step of every hypothesis test is actually to kind of state, what are you measuring? What is it you're dealing with? So we actually want to state the measurement. And then you also want to state what parameter you're actually dealing with. And remember, parameters are those numbers we calculate from the population, and we can't calculate those because even if I go back to this t-test thing, this is not the population. This is only 50 values from the population. So we can't actually find what the true mean is. And we can't really find what these values are, but we can in fact look at what we think is happening with them. So we're never actually going to get the real parameter, but we can at least talk about what it is. And so we want to state what measurement we're doing. So in this case, what did I measure here in this example that I'm dealing with?
Income level, income poverty level.
Okay, so we have income poverty level. But of whom?
People who own opposed to rent.
Yeah, so we actually have two different groups, don't we? We have people who own and we have people who rent. So we actually want to look at not just income poverty of each of together. We want to look at them as two separate groups. We want to look at these as two separate kind of individuals that we're working with. So we're going to have the income poverty of people who own. And then we're also going to have the income poverty level of people who rent. Now you can really see how bad of a typist I am. Okay. So we actually have two of these. And so what we might want to do if we have two of them is we might want to label them. And this is actually really, you can use words all you want. I have no problem with you using words instead of symbols. But I'm a mathematician by training also. And I'm lazy. Mathematicians are very lazy people. And you don't believe we are, but we really are. And that's why we came up with symbols. Because we don't want to write out income poverty level of people who own a home every single time. That we want to talk about it. So we give it a name. And unfortunately in mathematics, we use the letter X. And I actually hate the letter X, but we use the letter X. And I want this to be, there's two X's, right? Because there's two of them. There's the income level of people who own and income level of people who rent. So we're going to call this one X1, and I'm going to call this other one X2. If you want to try to do subscripts, you can. It just is neater looking, but I don't really care. All right, so now going back to my test up here, I actually have issues with with Zoom. Okay. I'm going up to here. What did we come up with? What are these values? What's this red line here and this green line here represent?
Mean.
They represent means. So they represent the center of this data set, and they represent the center of this data. And they're both sample means, right? Because they're from a sample. This, remember, is only 50 people that we looked at. So these are both sample values. We want to know about the population values though. So coming back over here, my parameter I'm dealing with is the mean income poverty level of people who rent. Oh, I'm sorry, who own. And then we have the mean income poverty level of people who rent. So let me fix my spelling here. All right. Again, we are lazy. We want to have symbols for these. Again, if you want to use the words, I'm perfectly happy with you using words and not symbols. I'm okay with that. I am, just because of who I am, I'm going to use the symbols. So I'm going to insert, because this is a Greek letter. These are population values. I'm going to insert a Greek letter. And so the symbol for mean is this weird looking U looking thing. And this one would be, because it's the mean poverty level of people who own, that goes with the X1, which was the income poverty level of people who own. So I'm going to call this one mu sub 1. I'm going to go ahead, because I'm in here, I'm going to go ahead and get my subscript. And I'm not very good at, there we go, with this. All right. And then I do the exact same thing for this one. I can actually just copy this and highlight this one and copy it. And then paste it here and then just change that 1 to a 2. That makes life a little bit easier on me. So you can do that a lot. So you can actually copy and paste these things all the time. And I'm just going to put equal signs here because that's what it represents. So the equal sign is just saying, hey, this represents this. Again, if you don't want to use the symbols, I'm okay with that. It's not the most important thing we're doing here. Okay. I don't want you to get bogged down on the symbols. You're more than welcome to use the words all you want. So now that we've done that, we know what we're measuring and we know what parameter we're dealing with, we can actually now start writing out what our hypotheses are. And again, we have this thing called the null hypothesis, which is HO. And we have this thing called the alternative hypothesis, which is HA. I usually start with HA. That's usually what I want to say. That's my research question. That's what I want to deal with. That's usually where I start. So I'm going to say what about these? I'm going to say something about mu1 as opposed to mu2. So again, this is what's nice about copying this. You can just copy. Whoops, what just happened? There we go. Is you can just copy and paste, and then you can just keep copying and pasting and not have to retype all these things. What I want to know is, what am I saying about it? So let's go back to looking at this graph. Unfortunately, every once in a while, if I'm inactive, it goes away, and so I have to come back and do it again. And what I'm looking at here is I'm saying that I think people who own a home have a higher income poverty level than people who rent. So what am I saying about mu1 as opposed to mu2?
It'll be lower than, it'll be lower.
The mean one, the mean of people who own is less than the mean of people that
No, you're
rent?
saying it'd be greater.
Yeah. Well, then, okay, it's greater. You just use that word, I'll throw that symbol in. Okay, so I threw that symbol in. The program that I'm working with right now actually doesn't care about being greater than or less than. It can just say, hey, it's not equal to. So we can also just say they're not the same. So this would be if I actually want to say the mean is greater for the people who own as the people who rent, or I could just say, I think they're different. If I'm going to say I think they're different, then what would I be saying here?
Equals.
Equals
So
if
for
they're different?
HO or for HA?
For HA, I'm still saying HA. So if I say that
It'll
they're
be
just different,
Equals then.
if I
Oh,
say
different
they're,
does not equal. So slash equals.
yeah, so it does not equal. So this, I use this one if I'm saying that the mean of people who own is more than the mean for people who rent. But if I want to actually instead look at the fact that I think they're just different, and actually just different is a very perfectly acceptable way to do things these days, then it would be not equal. So there is actually a not equal to symbol up here.
You have to
Just
hit
to
the new
find it.
equations first.
Oh, yeah, that's right. I keep forgetting that. There is a not equal to symbol up here. You can get that, or you can, if you don't want to find that, if you don't want to use that, you can actually also just write not equal. That's also fine, okay? So you can do not equal, and that's perfectly fine, or you can find the symbol. I don't care. So
Is
this
using like
is,
a slash with an equal sign okay as well?
that's fine also. Anything that gets the
Okay.
point across that you have, it's not equal to.
Okay.
So this is the mean of people who own is different than the mean for people who rent. And again, you can just use these words instead. You don't have to use these symbols, okay? I'm gonna use this HA of the not equal to. I think these days we're actually finding more and more people are accepting using that one. So we're gonna go ahead and do that one instead, but I just wanted to kind of point out it was there. All right, now we can go deal with this HO. The HA is really the thing you care about. The HO is just something we're gonna put in there, but the HA is really what we care about. And the HO is just, like I said, it's the assumption that you're seeing these differences, but it's just by pure chance. There really is no difference. So if there really is no difference, what symbol would you put here instead of this not equal to?
Would it just be equals?
It just equals. So your HO is always equals because you're always assuming there is no difference. Okay. And so HO always is this way. And again, you can just say, there's no difference. I don't care if you use the symbols. Okay. All right. So going back up here, My Zoom gets in my way sometimes. All right, going back up here to this. Again, now I'm going to look at this mean, and I'll see, hey, these means do look different. Okay? But I want to know, there's something else I have to consider. What else do we always consider when we're talking about data sets? We look at their center, and what else do we look at?
Many samples.
How many samples there? How many? Well, there's actually, I should be very specific. There's actually only in this case 2 samples. There's a whole bunch of data points in each sample, but there really are only 2 samples. Okay, so I want you to kind of get that terminology about we're only doing 1 or 2 samples, but we have lots of data points in there. But there's something else we also consider, not just the size of the sample.
Would be the confidence level?
Well, you don't know what a confidence level is yet, but
Okay.
there's something we've talked about in the past that we've actually mentioned. That not just the center, I've always talked about the fact the center is not the most important thing we deal with.
Median.
Standard deviation.
The standard deviation. The median is also important. The median is another way of measuring the center, but the standard deviation, how much spread is there? So it could be that we see this big change because there's a lot of spread between this data. Or we could see that there's not a big change, but there's not much spread. So the spread is actually very important. I'm actually going to show you something called a confidence intervals. You don't really know what they are, but they're kind of giving you a little bit of an idea of what the spread would look like. Not exactly, there's a little bit more to the confidence interval than just spread, but the spread is involved in this confidence interval. So one thing I noticed is that this sample shows a spread from down here all the way up to here. And this one shows a spread from here all the way down to here. So what do I notice first off about these 2 intervals?
One's way smaller than the other, or way shorter, however you want to put it.
The median of one of the height of the other.
They're similar to each other.
All right, so I'm hearing a bunch of different things. One thing I heard is that this one has a lot tighter than this one. So the red one's not as wide, it's narrower than the green one. I'm hearing that this one, the lower of this one, or the mean of this one is above the maximum of this one. What was the third one I heard? Sorry.
They're more similar now. They're closer together as far as, and they're not so like spread apart.
Okay, so there's not as much spread maybe going on. One of the things I notice is the bottom of this one overlaps with the top of this one.
Yeah.
So what the confidence level really is it's saying what the mean of this really is. So the mean we say is this line here, but it actually could be anywhere from this lower line to this upper line. So the mean for the people who own a home could be anywhere from a little bit less than 3 to about 4.2. Whereas for the green line, it could be anywhere from about 1.4 up to 3. I don't know where it is in there. I just know it's somewhere between those 2 numbers. So that being the case, if this one goes to a little bit less than 3 and this one actually goes to 3, what could that mean about these 2 means?
They could be the same.
They could be the same.
Oh,
So they could be exactly the same because these overlapped a little bit. If I took another sample, that may not be the case. So this sample, do they overlap at all?
no.
No.
They're actually pretty far apart by comparison.
If I did this one, now they're overlapping again. If I keep going with that, those are pretty close. They're almost touching. These are overlapping. These are definitely overlapping. So I can keep doing this, and these are definitely different. So again, your sample can actually show you results when there aren't any, or can show you there aren't any results when there really are. So that is the problem with statistics. And this is why I said before, you never know if your answer is right. So you never know if your answer is correct on these because you don't know, is it just the sample you got just didn't show it? Okay. All right. So one of the things we're going to do is we're going to find some way to kind of quantify this. And this is actually where we're going to kind of calculate this value. So the first thing we did was we took a sample. Okay. So we have our sample and then we're going to calculate. So the next, this isn't really the steps yet. We're going to kind of talk about what those real steps are in a little bit, but this is kind of outline the steps. The very first step here is the one up here where we kind of stated our measurements and the state and the parameter. This one here is where we actually stated a hypothesis. Then there's more steps that we can't really, there's another step that I can't really show right now because there's a lot of things we don't understand just yet, but there's some other steps that are in here. But then we're going to get to our calculation steps. And so this is actually where we go to collect the data. So I could do all of this stuff up here, these first 2 steps, and there's a 3rd step in here also, without actually collecting any data. This is actually what I want to do. This is what I want to find out. My hypothesis is what I'm trying to deal with. We're going to talk about the 3rd step here in a little bit. And then I can get to this calculation step, and I haven't actually collected any data till now. Now I'm going to collect the data. And then I'm going to find certain things. So what are some things that I calculated here? What was one thing we got calculated on here?
We got the range for the confidence interval.
We got the range for the confidence interval. Before we did that, what did we get?
Mean.
Just the mean. So the very first thing you do is you're going to calculate your mean. What did I also say we needed? I told you we needed something else to get.
Standard deviation.
Yeah, so calculate the standard deviation. All right, and then we can calculate what we're going to call the test statistic, which is really just the z-value. So we're going to calculate that z-value, the z-score, all right, which we calculated a little bit last time. We kind of talked a little bit about it and how to do that. I'm not actually going to show you how to do the calculation on it because it's really, really nasty. And then how do I know, how do I actually make a determination that I think there really is unusualness or not? What was the thing we calculated for unusualness or not?
It was whether or not it's 5%, if it's less than
Yeah.
or not.
So that must mean we need a probability. Okay. Now the z-score is actually what we call, because we're dealing with a test, this is actually called a test statistic. It's just this terminology for it. And then we're going to calculate the probability of being different than the test statistic. Don't worry, we're not going to do any of that by hand. R is going to do it all for us. The calculations can get really, really nasty and really, really hard, and especially if you've got really large data sets, which is usually what we have. So we're not going to do any of this by hand. We're going to let R do all of this for us. And in fact, this thing has actually done that for us. So I'm going to turn on one more thing. It's called the t-interval. You don't really know exactly what it is, but it basically is that test statistic that I was talking about. And notice it calculated my p-value here for me. So is this one unusual?
Oh, cool.
Yes.
Yeah, this one's really unusual because that's definitely less than 5%. You can actually go click on the statistics here and it will give it to you in a little bit different format where it actually gives you the data and so forth. And I'm going to show you how we get this calculation here in a little bit. But this is kind of what we're going to be doing and what you're seeing. But this p-value is definitely small. It's definitely unusual, right? So we compare it to that 5%, right? So it looks like, yeah, it does look like our p-value is really small. So it does look like, yes, we actually have an unusual thing. Right. Why the 5%? Where'd the 5% come from?
I don't remember.
Anybody else know? I know. I told it to you. Right? That's where the 5% came from. I told you 5%, right?
Oh, okay. I thought you were asking
Oh,
me
yeah.
if there was an actual reason.
No, you don't know anything more than that. You have no idea where that came from. You just know I was told 5%. And I
Okay.
told you at the time, I'll explain where that 5% came from. So this is where we're going to explain where that 5% came from. There are certain things that can go wrong in a hypothesis test. These are known as the types of errors, the types of things that actually can go wrong in a hypothesis test. And so there are actually only a couple places where we can make errors. All right, so the types of errors, we can say, if we say that HO is false, and it really is false, have we made an error? So if I say something's wrong and it really is wrong, have I said anything wrong? Have I made an error?
No.
No. So there's no error there. So if we say that HO is false and it really is false, there is no error. Right? If instead we say that HO is true, and it really is true, have we made an error?
No.
No, there's no error there either. All right. If we say that HO is false, and it really is true, we made an error. So again, think of it this way. If you say something's false, but it wasn't false, have you said something wrong?
Yes.
Yeah, you made an error. All right, so we made an error. All right, if we say that HO is true and it really is false, have we made an error?
Yes.
Yeah.
Yeah, we've also made an error there. All right. So we actually only have two places we can make errors in hypothesis testing. We have the error of saying HO is false when it really is true. That's one error. And we have the error of saying that HO is true when it really is false. That's your second error. Well, statisticians, being the most creative people they can possibly be, have given these names. And the very first one is called a type 1 error. And the second one is called what?
Type 2 error.
Type 2 error.
Type 2 error. See, we're so creative, aren't we? All right, so these are our two errors. So I'm actually going to write them out a little bit more in detail here. So a type 1 error, can't spell, is saying that HO is true, sorry, is false, when HO is actually true. And a type 2 error is saying that HO is true when HO is really false. Okay. Another way to say this is we're going to reject HO when HO is actually true. So this is another way to say this is rejecting HO when HO is true. And I will spell reject correctly. Okay. Where this one is actually saying, and we don't say accept, because we never.
Would you be
actually-
rejecting HA?
Well, no, because this is the thing is, this is where we have a little bit of the nuance in statistics. I'm making all of these assumptions and all of these conclusions on my HO. My HO is saying there is no difference, that everything I see is just by pure chance. Whereas my HA is what I really want to prove. All right, but HA is what I really want to prove, and HO is what I'm just using to help me get there. So everything I
So-
do in here is to assume HO is true and try to show it's not. What were you going to say, Jacob?
I guess based off of that, would you be rejecting that HO is false?
Or
I'm
what
trying to
I'm
figure how you
actually,
would word it then, without
I
saying
would actually
acceptable.
word it as failing to reject HO.
Oh, okay.
Okay. I don't want to accept HO. I want to say HO is false. I want to be able to say that because if I didn't want to say that, I wouldn't have bothered doing anything. This would not have been
Oh,
anything
right,
I've done.
Because
I-
HA is the one you're wanting to accept.
Right.
And-
HA is the one I want to prove. This is what I want to actually show. This is the one I'm assuming, and I don't really care at all about this one. I want to reject it. I want to say, hey, that's wrong. Throw that away. And the other one is what I want to actually prove.
I
So what
get
we
it.
do, it's a kind of a process in mathematics called proof by contradiction. We're assuming that HO is true. And then we're going to get enough evidence to say, hey, that can't possibly be true, which must mean that HA must be true. So it's this weird kind of proof that we do in mathematics. So we actually are going to fail to reject HO when HO is false. Now, so those are our two types of errors we can possibly have. Do you want to make errors?
No.
I think, no? Oh.
Yeah, I wouldn't think you want to make an error. I mean, I would hope these days we try not to make errors in our lives. Sometimes it happens where we make some errors, but we try to not make errors. So we really like the chance of making the error as small as we possibly can, which means we need to have some way of measuring these errors, these chances. Chance is a measure of what? How do we measure chance?
Wouldn't that be like a probability?
Yeah. So we're going to have a probability of a type 1 error, which is the probability, whoops, can't spell error. Probability of, still can't spell error. Well, you would think I could spell the word error. Okay. Is the probability of rejecting HO when HO is true. So it's just this probability, that's what we want to find. We want to find this out. We also want to look at the probability of a type 2 error. And this is the probability of failing to reject when HO is true. I'm sorry, it's false. I always get these backwards. So we have to give these names also because again, statisticians are lazy and we want to give names to these. We tried again really hard to come up with really impressive names for these. And the probability of a type 1 error we actually call alpha. And the symbol for alpha is over here in the Greek letters, it looks like that. So anybody got an idea what we call beta? The other one?
Beta?
Beta? Yeah, I said it by accident. All right, so this one's called beta. And I'm noticing people are chatting. Oh, somebody put beta.
No, it's just Jacob answering because I don't think he has a mic.
Okay, and Jacob, I know you would feel better to calculate it manually, but really you don't. I can show you the formulas, but they're not pleasant and nobody does them by hand anymore. And if you have hundreds of data points, you really don't want to do it by hand. The symbol for beta is right there. So there's your symbol for beta. So these are the things we have is these probabilities. Unfortunately, we don't calculate, well, actually, maybe fortunately, we don't calculate these. These are things that actually get assigned. We actually pick values for these, and that's how they come up with it. And so when I gave you the 5% before, it's because it's one of the acceptable numbers that we actually pick for alpha. There is another acceptable one that we see these days, and that is 1%. So the choices of alpha these days that we use are 1% and 5%.
So that's where that 5% comes from?
That's where that 5% comes from. It's
Okay.
one of the acceptable choices of where we see things. And again, I think that might be one of the reasons why the ASA says don't do hypothesis tests anymore, because really, why is 5% the number and not 3%? Why is that an acceptable level of error as opposed to 10%? So, but these are the two that we see these days most of the time is 1% and 5%. So now let's talk about beta. Beta is not chosen. but beta is also not calculated. Beta is actually not an easy calculation. To calculate alpha, really, we are assuming HO is true, and HO says, hey, they equal each other. So everything works out beautifully because there's a nice equal thing going. But here, with this, with the choice of alpha, with beta, we don't have that. We say HO is false, so we don't have this assumption that they're equal to. We don't know what they are. So calculating beta is actually not an easy thing to do. It actually is done through drawing different curves and doing some interesting calculations. But we can talk about how alpha and beta are related to each other. So that's the next thing I want to talk about is the relationship between alpha and beta. First thing I want to mention is 1 minus alpha is not beta. So they're not complementary to each other. So 1 minus alpha is not beta. All right. And 1 minus beta is not alpha. They're not complements of each other.
So
One
they're
minus-
completely unrelated in the sense of that.
Yes.
Okay.
1 minus beta actually has a value, and we actually say it's something called the power of the test. And we want to have tests that are fairly powerful, so you want beta to be fairly small so that 1 minus beta is pretty high so that you can have a lot of power in your test. And the way we get more power is to increase our sample size, and you'll see why in a couple of seconds here. Okay. So now that we have this, let's talk about the alpha and beta must be related in some fashion. So I do want to talk about the relationship between alpha and beta. Even though they're not complements to each other, there is some kind of relationship. And so I want to look at what that relationship is. And then I'm going to put a third one in there. I kind of alluded to it already, and that is the sample size. Which, remember, we use N for the sample size. So we're going to look at the relationship between all of these things. So alpha is the probability of rejecting HO when HO is true. So if alpha is really, really big, that means I'm rejecting, I could be making more errors, and that could happen because I'm rejecting more often. Can somebody who's talking in the background mute yourself? I don't know who that is. I might have to mute everybody. Okay. I muted somebody, and now we seem to not have the background noise. Okay. All right. So, Kellen, unmute yourself when you come back. All right. So, if I reject more often, if I'm making more type 1 errors, that means I'm rejecting more often. If I'm rejecting more often, what do you suppose that means is happening to beta or failing to reject?
Can you say that again?
So if alpha is increasing, if I'm rejecting more and more often, in which case I can make more and more type 1 errors, what could be happening to your type 2 error? What could be happening
Would
with
that be going
failing?
down then?
That would be going down because you're going to be, if you're rejecting more often, then you're failing to reject less often. And if you're failing to reject less often, then you have less chance of making a type 2 error. So if alpha increases, beta will decrease.
Okay.
For a specific sample size. So the sample size doesn't have to change there. If the sample size is a certain value, this will happen.
Okay.
Now, I would like both of them to be small. I don't want to make either errors. So if, let's say I fix my alpha to be a certain value.
Well, isn't
And
that what you'd be doing with the 1 or 5%?
that'd be the 1 or 5%. And I don't want to make a type 2 error. Then how do you suppose I could make less of an error? What could I do to make less of an error all around?
Make it that, well, I would raise alpha up a bit, so you
But I'm
lower beta.
I'm gonna fix alpha to be a certain value. I picked alpha
So
to be a certain
I do
value.
5% then.
Well, but I'm picking it to be a certain value. I still want to make beta get smaller.
Is there a way to measure the so as alpha increases potentially to where beta decreases to where both will be about equal?
There's not a way to
Okay.
actually measure that and make that happen because beta is actually a curve, and so it's really hard to do with that. But I
Okay.
can do something to make them both go down. So I can say I want my alpha to be this level, and I can make it to where beta is going to come down. What will do it? What can I do to make less and less and less errors?
Bigger sample size.
A bigger sample size.
Oh,
So
that makes sense.
if alpha is fixed at a certain value, beta will decrease as the sample size increases. Because if you think about it, if you have more and more data, you're going to have a less and less error because you have more and more of this of the population altogether. So those are the two relationships we actually have, is that if alpha increases, beta will decrease. And if alpha is fixed and the sample size increases, beta will also decrease. So that's what we want to kind of happen. We always want them all to go down. So now let's talk about how do we pick which alpha. All right. And this has to do with the consequences of making an error. So consequences have nothing to do with statistics. This is not something that you will get from this class as to what consequences are. Consequences are things that happen to you. So as an example, and I hope my son doesn't hear me, because he's of course home at the moment. If my son didn't clean up his room before spring break was over, I was going to take away all of his screens. So what was the consequences of him not cleaning up his room?
You confiscating his stuff?
Yeah.
Taking away all of his screens. So those were his consequence of making that error of not cleaning his room. By the way, he cleaned his room. So everything's good. If I don't file my taxes by April 15th, what happens?
You can get IRS issues.
Audit?
I not necessarily an audit. I'm going to get a fine, not just an audit.
Yeah.
I will get fined. I will get issues from the IRS. So those are the consequences of making that error. My error was I didn't fill in my taxes on time. Okay, which I need to do. I gotta get my taxes done.
I think they extended the tax time.
I have no idea. I don't pay attention. Mine are done. I just have to finish them up. So these are the kinds of things that I have to think about of what kind of things can go wrong. So when I'm picking my alpha, if the consequences of a type 1 error are really, really bad, and the consequences of type 2 error are not as bad, then what do you
That's why I want to go with the type 2 error as what I would choose as, if I had to choose an error, I'd go with that one.
Well, I go with the type 2 error, but remember, I can only choose my alpha level. So which
Oh.
alpha level would I choose? If I
1%?
don't, 1%. Yeah, because I don't want an alpha, I don't want a type 1 error to happen. So if the consequences of a type 1 error are really, really bad, you're going to choose 1% for alpha. And that's it. Otherwise, if anything else, you're going to pick 5%. Okay? Now, I still like to consider my type 2 errors. So I always have to look at what the different consequences are. So I actually should say the consequences of a type 1 error are really bad, and the consequences of a type 2 error are not so bad. So it's the consequences that I'm looking at. So you want to think about what would happen if you made this error. And to give an example, a couple years ago, well, what, almost 4 years ago now, think about it. 3 years ago, I guess it was. We had a presidential election, right?
Yeah.
And does anybody remember what the polls were predicting who was going to win that election?
Wasn't it Hillary?
A lot of the polls said Hillary.
Yeah, a lot of the polls said Hillary. All right. So a lot of the polls said, hey, Hillary's going to win. Is that what happened?
Nope.
No.
Nope.
So that's not what happened. But one of the companies, one of the gun companies, gun manufacturing companies, got really, really worried that Hillary was going to win and that she was going to put in place a gun control values, and that people were going to get upset and have to go buy guns before that happened. So they listened to the fact that Hillary was going to win. They used the sample data they had to say that Hillary was going to win, and they're like, oh, we better have more guns because we're going to suddenly get an influx of people wanting to buy guns right after the election, and we better make sure we have a whole bunch of guns on hand. So they went and manufactured a bunch of guns so they'd have all these guns on hand. Okay. Is that what happened? No. Hillary didn't win. So guess what happened?
They just had a surplus of guns now.
They had a surplus of guns, but you spend money to make the guns. Okay. So you had to outlay a bunch of money to do this. And so they were suddenly out a bunch of money and they weren't making the money back from selling the more guns. So they made a type 2 error. They assumed that HO was going to be false when it really, I'm sorry, they made a type 1 error. They said HO was going to be rejected when HO really was not. They made a type 1 error, and the consequences of making that type 1 error is that they made too many guns and had a stockpile of them. And they had to outlay a bunch of money to do it. So actually, they went bankrupt.
Oh, wow.
So there are real life consequences to making these errors that we have to actually think about. Okay. So now I want to go back to the example that we're dealing with right now. And I want to talk about what are the different errors that we have, and then what those values come out to be. And I totally am way off on my notes, so I apologize for this. I'll get rid of all these. But we're going to go ahead and do it for this example that we're dealing with of finding this stuff out. So let's look at, for the example, what would the errors look like? All right, so for income poverty level, so a type 1 error. So what is, a type 1 error would be saying that HO is false, and HO is saying that there is no difference. So a type 1 error is saying HO is false when it really is, or is, we say that HO is false, sorry, which one? Type 1 error is saying HO is false when it really is true. So this would be saying that there is no difference when there really is one. And so we could say there's a little bit more in words than that, would be saying that there is no difference in income poverty levels for people who rent versus own when there really is.
Yeah.
Okay. So that's your type 1 error. There is no difference, saying there's no, and actually I should say it this way because this isn't really doing something. This is actually, I want to say you're saying that there is no difference in income poverty level of people who rent versus people who own when there really is a difference. What would a type 2 error look like?
Will that be saying that
Saying
they're,
there's a difference when there is none.
yeah, that.
Okay. I really am a pretty good typist. I don't know why I'm doing so badly. Maybe it's because you guys are all watching me.
Under pressure.
Yes.
That's always the case. You're always good until someone's watching you do it, and then you make all the mistakes.
Okay. So those are my type 1 and type 2 error. So notice so Jacob, yeah, the sales didn't spike, and that was the issue, is the sales didn't spike after the election, and that's why they lost their money. So it was their manufacturing, not their selling. They wanted them to spike, but there wasn't one. Okay, so going back to here, we now want to talk about the consequences these would be, okay? And that really, I can't answer those for you. I am not always the person who can answer the consequences because it's not something that might be personal for me to come up with. But let's say we actually say that there is no difference in income poverty levels for people who rent versus own. So what might that mean if I don't think there's any issue between people who rent and own a home and their poverty level? What could that mean I might do just in life?
Low income housing might decrease if they think there's no like poverty difference.
So we could say maybe not decrease, but the need for low income housing may be diminished, or maybe not diminished, but maybe we should say low income housing might disappear. Maybe diminished because a need is not seen. So that's a big difference, right? Is that the big thing that could happen? Is that we might actually get rid of low income housing, may just diminish because no need is seen. That's a big issue. What about a type 2 error? What could be a consequence in that case? This one is saying there
Increase
is
of
a
low
difference.
income housing, or
So we could be spending money on low income housing. If I spend money on low income housing when I don't need to, what could that mean?
higher taxes.
Yeah, I could have higher taxes. What else could I have? So if I spend more money for low income housing, what happens?
It gets more
You said spend
expensive.
more money for low income?
Well, for low income or?
What did you just say?
So if I spend more money for low income housing, what has to happen?
You have to spend less money somewhere else.
Yeah, other things will lose money. So I might be spending more money on low income housing when I don't need to, and other funding goes down. I don't know why it goes down. So that means other things might not get the funding that they need, right? So these are all issues that we look at, and there are other consequences that you may come up with depending on your point of view. You might have a different point of view and come up with different consequences. And now what I want you to determine is which one seems to have worse consequences.
Type 1.
Okay.
Type 2.
Type 2, I'm hearing both. And again, this is also your point of view. All right. So let's think about this for a moment. If we actually do have, let's suppose the majority of you think it's a type 1. Then which alpha would you pick?
1%.
The 1%. Now, this is kind of what you have to go through every single time you do this, is kind of the same discussion and wherewithal going on, is you kind of go through this. But you would go through all these discussions and see what's going on and pick your alphas. Now, in the homework, I'm going to tell you which alpha level to pick. I'm going to give you those for the homework where you have to actually do the calculations. Some of the problems actually in the homework ask you to pick an alpha level and talk about the consequences of them and then which one they are. But we don't have a really good idea about that. And you have to kind of go up with that. But if the problems where you're actually doing the hypothesis test, you're actually going to be picking the alpha level that you need. Okay. I mean, you're going to be told what alpha level. We're going to do a project over hypothesis testing and you're going to pick your own. And I always get this question, well, what's the right answer? There is no right answer. It's what you argue. What do you think the worst is? What do you think is best? What do you think the consequences are? There's no answer to any of these because everybody has their own idea of what consequences are and what they could be. Because sometimes it depends on your point of view. If you're a company that is trying to say that there's not a lot of problems with low-income housing, you probably don't mind making a type 1 error because you want to be able to say there's no difference. So it all kind of depends on what you're dealing with, okay, and your point of view. All right, so now we have that part down, and now we can actually get to our conclusion. So we've picked an alpha of 1%. All right, so our alpha is 1%. From our test, which I don't know if still is up. No, it's not. So we're going to get a new p-value. All right, so I'm going to go back to my poverty and my home type. And I'm going to go ahead and put in my means. I'm going to go ahead and put in this t interval that I talked about, which really is this test statistic. And there's my p-value. So now I've done my calculations and I'm ready to go. And what is my p-value in this case?
0.0002 or 3 if you
All right,
round up.
so, and the p is 0.0002, was that it? Something like that?
Or 3 if you stop it there because the next digit is 5.
Okay. Oops, 3. All right. So now comes the part of what we have to do here. Okay. So now the part is, is that we have to now try to figure out, do we actually say that we're gonna have enough evidence to prove our HA is true? So that's what we really want to do. We want to get enough evidence to show HA, to support HA. And so we need to see, is this unusual? So this gets us to the idea of something called the rare events rule of statistics. And I actually wrote this before, but I'm going to write it again. And what the rare event rules of statistics says is if see how to say this right. Trying to think of how I want to say it. I always say it somewhere different every single time I do this. If under, give an assumption. If an observed value of a parameter or let's just say an observed value is found to be unusual, then the given assumption is most likely false and can be rejected. In a hypothesis test, we are assuming that HO is true. So that's what we're doing in a hypothesis test, is we are assuming all right, we're assuming it's true. If we find something that's very unusual, and the way we determine unusual is by comparing it to that alpha level we just picked, then we can actually say HO is rejected. So if we are assuming that HO is true, if we find an unusual value, which means the p-value is less than the alpha level, then we can, in fact, reject that HO. Throw it out. It's not true. We're going to assume it's true. We're going to find something that's unusual, and then we can say, eh, that must not have been true. And so that's really what we're doing. So in this case, are we rejecting HO or failing to reject HO? Is my p-value less than my alpha level?
Yes.
Yeah. So if it's less than it, what can I do?
Say it's true.
So the p-value is less than the alpha level. Since 0.0003 is certainly less than 0.0501. All right, so we are saying that. So we assumed for the moment that there was no difference. We assumed that HO was true, that there was no difference. We now found something that was unusual. So what can we do to this HO?
Okay.
So what does this say we're going to do if we find a p-value that's less than our alpha?
Reject it.
We're going to reject it. So that's what we can do. We can, since my p-value is less than my alpha, I can reject HO. That's it. That's my whole conclusion. Okay. Now the problem is you're like, I don't know what that means. This isn't very helpful. And you'd probably, whoever's got background noise, can you please mute yourself? Or I'm going to mute everybody. Okay. So what we're going to call the interpretation is what we're going to do next. And the interpretation is, what does that mean? So I'm going to reject HO. Okay, what does that mean? I have no idea what that means. So what I want us to come back up here is look at what our alpha level was, or what our hypothesis were. Our hypothesis was that there was no difference, right? That there's no difference in the mean for people who own a home and the mean for people who rent a home. And I probably should have been a little bit more exact here and said the mean income level or income poverty level of people who own a home as opposed to the mean for people who rent a home. So I'm saying, my HO is saying, hey, there was no difference. So I'm rejecting this. I'm saying I assume this to be true, that there was no difference. So everything I saw was just pure by chance. I'm saying there is no difference. That is being rejected. I'm saying, no, I don't believe that. So if that's being rejected, what can I say? So again, what was I trying to prove?
There was no difference.
Was I'm trying to prove there's no difference? What was my question originally? And I never actually wrote it down, but
There is a difference.
yeah. So I want to say, is there a difference? So this HO said there's not a difference. What does the HA say? Remember, HA is what I'm trying to prove. What did HA actually say?
Yeah, it says that there is a difference.
There is a difference. HA was saying that there is a difference. So we're trying to prove that there
HO
is a
false?
difference. What was that?
HO was false.
Well, HO we just rejected. HO is rejected. So this statement here, I rejected it. I threw it away. It's gone. So if it's gone, I rejected it. That's all that's left. So what's left is
All right.
there is a difference. So that means my interpretation really is there is evidence, because it may not be true, to support that there is a difference in income poverty level between those who own a home and those who rent. And I'm good. I'm done. I proved I have enough evidence to show what I wanted to show. Now, the problem is, of course, I have evidence for it. Doesn't mean it always will be the case. If I go back to this again, I could have just by chance this one's still showing an error difference. But if I could have by chance gotten this one. Wait, whoops, I had one too. Oh, this one. This one is 0.05. So would this one have shown there was a difference? Would I have been able to reject HO in this case? My p-value is 0.05. So Jacob says it's above 5%. So if my p-value is more than 5%, it's more than the 1% that we set, right? So in this case here, there would not be evidence for me to actually reject HO. I'd have to fail to reject HO, which means in this case, I don't have the evidence to say there is a difference because they overlap. There is, looks like there's no difference there. So this is the problem with hypothesis testing and anything we're doing actually in statistics is my conclusions very much depend on my sample. Now, here's another interpretation of which we're out of time, but I was gonna say another interpretation of alpha level is that if I did this new sample 100 times, 95% of the time, I would be rejecting HO if my alpha was 5%. So 5% of the time, I'd fail to reject HO. I'd make an error. And 5% and 95% of the time, I wouldn't. So that's kind of what this goes with. All right, we're actually out of time. Next time, I'll kind of do a little bit more with this. I actually would like you to go ahead and fill in this part here where we're kind of talking about what these values would be and what your hypothesis tests are, what your hypotheses would be. So if you can do that kind of on your own, just kind of fill these in and see what you come up with, just to kind of get a little bit of discussion with this, and then also what your conclusions would be. So this is kind of your group work on your own, is fill in these information just a little bit on your own, just to kind of get an idea of what they are. So just the end of this, go ahead and finish this before next class period, and then we're going to actually show you how we kind of calculate things and put things together. We've done no calculations yet. This is not about calculations. This is just about understanding the whole idea behind hypothesis testing. We haven't done anything actually yet to do anything. And then next time we'll actually do some examples. Yes.
So do you want us to just go ahead and write those in on a separate piece of paper and then next time we meet over this video chat, discuss it? Or is that what you're saying
No.
for it?
You can actually put your answers right here. And then if
Okay.
everybody puts their answers right here, we can kind of look at them really fast and see if anybody had any issues. It's more of
Okay.
just to make sure this is not going to be graded. This is not saying, hey, you're right or wrong. I just want to see what people come up with.
Okay.
Okay, so just kind of put in some information about what you think these would be and to kind of get some ideas just to help you. And you can look at other people's answers because they're obviously going to be there at some point. And you can all just kind of put your answers in there and then we can just look at them real fast before class next time, at the start of class. Okay? All right. So remember the test for chapter 6 is due on Monday. Everything's due at 11:59. So your homework for chapter 6 is also due tonight at 11:59. I will try to grade it tomorrow. I will post the solutions tomorrow also. And I think that's everything for today. We're a little over. I apologize for being a couple minutes over. Okay. All right. So
Everyone
thanks.
have a great weekend.
You all have a great weekend too.
Bye. Thank you, Kate.
Bye-bye. Thanks, everyone.
Bye-bye.
Bye.